Right, so just review this. So this is the model that we're going to work with for GCSE and that we've just described there. So we've got our nucleus here, and that contains my protons and my neutrons in here. But that's tiny. Atoms are small anyway, and the nucleus is really, really tiny. And then whizzing around here are my electrons. Now there are certain terms and certain ways that we use to describe atoms. So there's key words we're going to look at now. There's something called the atomic number. The atomic number tells you the number of protons in an atom's nucleus. So if you look at a periodic table, you will notice that every atom we start, hydrogen has a 1. The 1 is hydrogen's atomic number. Every atom of hydrogen has 1 proton in its nucleus. Let's pick another one. Carbon. Look at your periodic tables. What is the atomic number of carbon? It's 6. 6. So, how many protons does every atom of carbon have in its nucleus? It's got 6. Yeah, brilliant. So that's the atomic number. So if someone says to you, how many protons are in an atom of copper, all you need to do is skip off, find the nearest periodic table, you'll find the atomic number of copper is 29, so it tells you straight away there are 29 protons. Right, so every single atom is neutral. So let's have a look, let's go back to carbon. If carbon has 6 positive particles called protons, how many electrons must it have? Yeah, 6, yeah. So from that, they must always balance. So an atom, however many protons it has, it must have the same number of electrons. So from that one number, I can find out how many protons I've got and how many electrons I've got. What's the one particle you don't know about? Neutrons. For the number of neutrons, I need to tell you something which you can't find out from the periodic table. And I need to tell you a number called its mass number. An atom's mass number is the number of protons plus the number of neutrons. So if I was to tell you, I've got an atom of carbon and its mass number is 13, how many neutrons has it got? What would you do? You'd say I've got 13 protons and neutrons. I know 6 of them are protons, and therefore I must have 7 neutrons. So as long as you've got a periodic table and you know its mass number, you're sorted. So let's do another one. I've got an atom of potassium. Potassium, and its mass number is 40. How many protons and neutrons has it got, and electrons? Well, the atomic number of potassium is 19. So that means it's got 19 protons and 19 electrons. How many neutrons has it got if its mass number is 40? 40 minus 19 is 21. 21, yeah. Maybe we use our calculators for that one. So chemists are pretty lazy, really. We try not to write too much, if possible. So what we like is we like to have a shorthand that we can represent atomic number, mass number, and everything all in one. So I've got a lithium atom. Let's try and do. So if you look on your periodic table, the lithium atom, I put the symbol Li for lithium. The atomic number of lithium is 3, so that number goes down the bottom, and then so that's going to give me my 3 protons. 3 protons there. The mass number of this lithium atom is 7. So how many neutrons do I need to pop in my nucleus? 4. So let's put my 4 neutrons in here, like so. And now how many electrons do I need to stick around, orbiting around? I need 3 electrons because I've got 3 protons. So this is the shorthand way of representing. Mass number goes there, atomic number goes there, and then you've got your symbol there. So let's do another one, carbon. What's the atomic number of carbon? If you look on your periodic table, it is 6. So, how many protons do I need to stick in my nucleus? Let's do that. There we go. My mass number is 12. So how many neutrons do I now need to pop in my nucleus?
6.
So let's do that. 6. And now how many electrons are going to orbit around? 6. There we go. Happy days, I've got 6 electrons. Okay, cool. So for the electrons, they don't just go randomly around the nucleus. They're into specific shells. So what we're going to do is we'll do a little table. So we'll do shell number and number of electrons it can hold. Now the rules are really easy, so they're dead easy to remember. So the first shell, shell number 1, that's the one closest to the nucleus, can only hold 2 electrons. Shell number 2, the next one out, can hold 8 electrons. Shell number 3, and I'm going to lie to you now, but it will get you through GCSE, will hold 8 electrons. 18, but for GCSE it only holds 8. And shell number 4, you're ever going to need to put 2 electrons into that shell, so we're just going to pretend it can also hold a maximum of 8. But I'll be perfectly honest with you, that's not the truth, but it will get you through what we need to do for GCSE. So our first example that we're going to do is carbon. Carbon has an atomic number of 6. So how many electrons does it have?
6.
Therefore 6 electrons, because the number of electrons must equal the number of protons, which is atomic number. So if that's my nucleus, the way I describe it is I do put little arrows, little crosses as the electrons. So how many of my 6 electrons can go into my first shell? 2. So I'm going to put 2 little crosses like so. And into shell number 2, I've got 4 left over. So 1, 2, 3, 4, like so. Now that gets really tedious doing it that way. So I can simplify that by just putting 2, 4. 2 electrons in my first shell, 4 electrons in my second shell. Because it saves having to do circles. So shall we do example 2? And let's go mad. Let's do potassium. I know, it's bonkers. What's the atomic number of potassium? Yeah, what was it? Sorry? Atomic number equals 19. Yeah. So how many electrons has it got? Electrons is going to be the same, isn't it? Electrons equals 19. So, there's my little nucleus. Let's do my little shells. You'll notice my circles get really dodgy. How many electrons in my first shell? 2. How many in my second shell? 8. So 1, 2, 3, 4, 5, 6, 7, 8. That's 10. How many in my third shell? 1, 2, 3, 4, 5, 6, 7, 8. How many have I got left over? 1. So 1 in my final shell. Make it easy. 2, 8, 8, 1. Like so.